All right, you guys sent us this article
Yeah.
about like a potential connection between some kind of mysterious atomic discovery
Oh, wow.
and dark matter.
Hmm.
So it's from SciTech Daily,
Okay.
and it's titled, "Could a Mysterious Atomic Discovery Unlock the Secrets of Dark Matter?"
Wow, that's a pretty big claim.
Right.
Yeah.
But it's about these scientists who, it seems like they found something completely unexpected while they were studying something else entirely.
Interesting. Like a scientific plot twist?
Totally, a total plot twist.
I like it.
So what do you think? What did they find?
I don't know. How could it even be connected to something as crazy as dark matter? It's so elusive.
Right.
Yeah.
It's like the biggest mystery in like the universe.
Yeah.
So let's
dive in.
let's dive into this Ytterbium anomaly.
Ytterbium anomaly. Okay,
Yeah.
I'm ready.
So the article starts by talking about this 2020 discovery at MIT.
Okay.
And these researchers were looking at isotope shifts in ytterbium.
Right, those atomic fingerprints.
Right, yeah, like the fingerprints
Yeah.
that help us tell these different isotopes apart.
Exactly, yeah.
Yeah.
They're unique to each isotope.
Yeah.
Yeah.
Uh-huh.
But they were expecting to see, like, a certain pattern in these shifts, right?
Right, they were
But
expecting...
Ytterbium kind of decided to break the rules. They found this nonlinear deviation in the shifts, which basically means, like, things weren't lining up the way they should.
So it's like they were expecting a straight line, but they got like a curveball instead.
Yeah, exactly.
What could even cause that kind of like deviation?
That's the question, right?
Yeah.
That's what we're trying to figure out.
Yeah.
This kind of nonlinearity suggests that something fundamentally new might be happening, like something we haven't thought about before. It could be something to do with the structure of atomic nuclei.
Okay.
Or maybe the forces governing them.
Okay.
Yeah.
Now I'm like really intrigued.
Yeah.
So is it possible that this is like our first glimpse into the world of dark matter?
Oh, wow.
That's what the article seemed to kind of suggest.
It's a very tantalizing possibility, isn't it?
Right.
We know dark matter exists
Yeah.
because of the gravity, its effects.
Right.
We have no idea what it is.
Yeah.
It's like, there's an invisible elephant in the room.
Right.
Because you keep tripping over stuff, but you can't see it or touch it.
That's such a good analogy.
Right. It's just there.
Yeah.
But we don't know what it is.
So could this like tiny anomaly, in an atom's energy levels be like our first clue to finally understanding dark matter?
I mean, it's definitely a possibility, and it has a lot of physicists excited.
Yeah, I bet.
If it is caused by a new dark force that interacts with both dark matter and ordinary matter, that's a huge discovery.
That would be groundbreaking.
Yeah. That would rewrite the textbooks.
Totally, the physics textbooks.
Yeah, for sure.
So the article also mentioned some researchers from Germany.
Right, yeah.
Who took a closer look at this anomaly, right?
Yeah.
Like they wanted to kind of dig in a little deeper.
Yeah, they were from the Physikalische Technische Bundesanstalt.
Wow, that's a mouthful.
Yeah, PTB for short.
PTB, okay.
And the Max Planck Institute for Nuclear Physics.
Okay. All right.
They teamed up.
Okay.
And they used really precise measurement techniques.
Okay.
Like ion traps, mass spectrometers, ultra-stable lasers.
Wow.
Like the best tools we have to study the atomic world.
So like they really went all out.
They did.
To make sure that this anomaly wasn't just like an experimental error.
They wanted to be absolutely sure.
Yeah.
And their findings were really something,
Okay.
Not only did they confirm what the FIT researchers found,
wow,
but they also ruled out some possible explanations that might have been due to flaws in the experiment.
So the ytterbium anomaly is the real deal.
It seems so. Yeah.
Does that mean that we found evidence?
Hold on.
Okay.
While the search for those dark forces is still going on.
Okay.
This research actually showed something else. Pretty amazing.
Okay, what is it?
It gave us a new perspective, on the structure of atomic nuclei themselves.
You mean the heart of the atom?
Yeah, exactly.
But I thought we knew a lot about those already.
We do. Yeah. But there's always more to learn.
Okay.
You might think of nuclei as perfectly round, like a little sphere, but actually a lot of them are deformed.
What?
Yeah, they're slightly elongated or flattened.
So they can be different shapes?
Yeah, like a football or like a squashed beach ball.
Wow.
Yeah.
That's wild.
It is.
That atomic nuclei can have different shapes. And this research actually shown that the deformation of ytterbium nuclei changes along the isotope chain in a way that wasn't predicted by the current theories. So that means our understanding of nuclear structure needs some, like...
Yeah, it might need some tweaking.
Tweaking, yeah. So this unexpected deviation is pushing us to kind of rethink how atomic nuclei behave.
Exactly. It's like we were playing a game with one set of rules, and then Ytterbium came in and said, no, we're changing the game.
Wow! This is so fascinating.
It is.
But the article also mentioned something about neutron stars.
Oh, yeah.
You know those crazy...
fascinating objects.
Right, like incredibly dense remnants of collapsed stars.
Yeah, they're like almost entirely made of neutrons.
It's just like mind-boggling.
Packed in super tight.
Right, so what do deformed nuclei have to do with neutron stars?
Well, that's where things get even more interesting.
Okay.
You see, the way ytterbium nuclei deform gives us clues about how neutrons act under extreme pressure.
Okay.
And that's exactly what you find inside neutron stars.
So by studying these like tiny little deformed nuclei, we might actually learn something about these massive, incredibly dense objects in space.
It seems counterintuitive, but yeah.
Wow.
It shows you how interconnected different areas of physics can be.
Yeah.
What started as a potential clue to dark matter might actually help us understand the crazy conditions inside a neutron star.
This is blowing my mind.
It's pretty wild, isn't it?
Yeah, it seems like we've uncovered this whole other layer of complexity in the universe, and we've only just...
It's just scratched the surface.
Scratched the surface. I think we need a moment to process all of this.
I think so, too.
Yeah.
It's a lot to take in.
It is a lot to take in. Yeah. So join us in part 2, where we'll discuss what this all means.
Yeah, what it all means.
And what other research is being done to kind of solve this mystery.
Yeah, there's a lot more to come.
All right, we'll be back.
See you then.
Okay, I'm still, like, trying to wrap my head around all of this.
Yeah.
We've got this tiny atomic anomaly, and it could be connected to dark matter.
Pretty wild, right?
It is, and it's teaching us about the shape of atomic nuclei. And somehow, it might even help us understand neutron stars.
Yeah, it's amazing how one little discovery...
It is amazing.
...can have such big implications.
Yeah, totally. So where do we even go from here?
Right.
Like, what are the next steps in unraveling this Ytterbium anomaly?
Well, one thing's for sure, this is just the beginning.
Oh, yeah.
Scientists are, like, pursuing all sorts of research to try and figure this out.
What kind of research?
Well, for one, they're pushing the limits of precision measurement. You know, the more accurately we can measure these isotope shifts, the more likely we are to find those subtle details that could tell us what's really going on.
So it's like a race to build even more sensitive instruments.
Exactly.
And gather more data.
Yeah, more data, more precision.
Okay.
And that data will be key to testing the different theories.
Right, because we talked about the possibility of a new particle.
Yeah, maybe even a new force.
Right, those are big ideas.
Huge ideas.
We need some...
solid evidence.
Evidence?
Yeah.
What kind of evidence would convince scientists that this anomaly is caused by, you know, something totally new?
Right. That's a good question.
Yeah.
One thing they're looking for is consistency.
Okay.
You know, if we see this anomaly in other elements besides ytterbium,
okay,
or if it, you know, behaves in a way that matches what the theories predict,
right,
then that would be pretty convincing.
Okay, so it's not just about observing the anomaly itself.
No.
But about how it behaves?
Exactly. Okay. Whether it fits into a bigger picture.
Yeah, okay.
And that's where the theoretical physicists come in. They're working hard, trying to develop new models to see if they can explain this anomaly with the physics we already know.
So it's this like constant back and forth between like the experiment and the theory.
Yeah, like a dance trying to make sense of the universe.
And sometimes that dance leads to a breakthrough.
Totally.
I love that.
It's exciting.
It's what makes science so exciting. It's not about being right or wrong. It's about constantly like questioning, exploring, finding our understanding of like the world around us.
The ytterbium anomaly is a perfect example of that.
Yeah, it really is.
It's like a challenge. It's a puzzle.
Oh, puzzle, yeah.
And an opportunity to learn something big.
Yeah, it makes you wonder what other mysteries are out there just waiting to be discovered.
Exactly.
Are there like other theories about what might be causing this anomaly besides like the new particle idea?
Yeah. Not everyone thinks we need new particles or forces to explain this. Some people think that maybe we just need to like understand the forces and interactions we already know.
So you're saying like our current models of like the atom, specifically the nucleus.
The nucleus,
could be incomplete.
They might be,
Wow.
We might need to like refine our understanding of the strong nuclear force.
Right, the one that holds the nucleus together.
Exactly, yeah.
Right.
Or maybe there are quantum effects that we haven't fully considered.
So it's not necessarily about like throwing out our existing knowledge.
No.
But about, like...
building on it. Expanding it.
Expanding it.
Refining it.
Yeah.
Sometimes, the biggest discoveries come from realizing that what we thought we knew is just a simplified version of a much more complex reality.
Wow, that's a really cool thought.
It is, right.
It makes you realize that even in fields where we think we know a lot, there's always
more to learn.
Yeah. I love that.
And that's what makes science so great.
Yeah.
It keeps us humble.
Trumbull, right?
Yeah. It reminds us we don't have all the answers.
Yeah.
And that's okay.
It's okay to not know.
It is. In fact, it's the questions that drive us forward.
The questions.
Yeah, the mysteries that keep us searching.
And sense like a theme here, like a sense of wonder.
Definitely.
And like a reminder that even the smallest anomaly can, like, shake the foundations of our understanding.
You can.
Makes you wonder what this means for the future of physics.
Right.
And maybe even, like, our place in the cosmos.
That's a great point.
Yeah.
And it's a perfect lead-in to the last part of our deep dive.
Okay.
We're going to look at the long-term implications of this research. And explore what it might mean for how we understand the universe as a whole.
Wait. Okay, so we're back for the final part of our deep dive into this Ytterbium anomaly.
Yeah.
We talked about the discovery, the possible explanations, and all the different ways scientists are looking into this.
It's a lot.
Yeah, but what does it all mean, like, in the grand scheme of things?
Well, I think one of the big takeaways is that even something as small as an anomaly in the energy levels of an atom can have huge implications.
Right. It's crazy to think.
Yeah, it shows how much we still have to learn.
About the universe and how it all works.
Yeah.
It's full of surprises.
Definitely.
So this Ytterbium anomaly highlights how connected science is.
Yeah.
We started by looking into atomic nuclei. And it might teach us about dark matter, neutron stars, maybe even the fundamental laws of physics.
It's wild, right?
Yeah, so this is much bigger than just one weird element on the periodic table.
Oh, absolutely. This could mean that our models of physics aren't complete.
Like there's a whole other layer of reality out there.
Exactly.
That's mind-blowing.
It really is.
So what happens if this anomaly really is caused by something totally new, like a new particle or force?
Well, it would be revolutionary for particle physics.
Okay.
It would mean there's more to the universe than we thought.
Right.
And it would open up so many new areas of research.
What kind of research?
Well, we'd need to figure out all about this new particle or force, how it interacts with other particles, its mass, things like that.
Okay.
And then we'd have to rethink our models of the universe.
Like adding a new piece to the puzzle?
Yeah, and then figuring out how it changes the whole picture.
Exactly. And it's not just particle physics, right?
Right.
If this is connected to dark matter, like some scientists think,
yeah,
it could help us understand what dark matter actually is.
We've been searching for that for so long.
Decades, yeah.
So it's possible.
That would be huge.
Even if it's not dark matter,
this
research is still super important.
Okay.
It's pushing the limits of what we know.
About nuclei, neutron stars, yeah.
And it's making us rethink basic assumptions about the universe.
So no matter what the explanation is,
yeah,
this research has already done a lot for science.
Definitely. It shows how even small discoveries can lead to big changes.
And how we understand the world.
It all comes back to the scientific method.
Yeah.
Observing, experimenting, and refining our theories.
It's inspiring to think about all these scientists working together.
It is. It's amazing.
To solve these mysteries.
And who knows what else is out there.
Right. What other secrets are waiting?
Maybe even more mind-boggling anomalies.
Hiding in the data.
Just waiting to be discovered.
This deep dive has given me a lot to think about.
Me too.
I'm going to look at the periodic table a little differently now.
Yeah.
Knowing that those elements could be hiding secrets that could rewrite everything we know.
That's the beauty of science. It never ends.
The never-ending journey.
And we're all part of it.
That's a great way to put it.
Yeah.
So to our listeners, we hope this deep dive has sparked your curiosity about the universe and all its mysteries.
Yeah.
The next big discovery could be right around the corner.
Who knows?
So keep explore, keep learning, and maybe you'll be the one to unlock the next big secret of the cosmos.
You got it. 26th day,